Okay guys, I'm now coming to you talking about 10.3 part 2, which is arc length. In order to understand arc length, you have to understand circumference because arc length is merely a portion of the circumference, okay? So this basically, we're given either degrees or radians. Radians in this case is really, really easy. In degrees, remember guys, an entire circle has 360 degrees. So it's just a basic ratio, small over big equals small over big. So in this case, arc over circumference, so portion of circle over the entire circle, is equal to the angle measure, which is given, over 360 degrees, which is the total degrees possible. Now in this case, you also might be given a radian measurement. Now remember, radians are already a ratio around the circle with how many radii go all the way around the circle. So this is just simply arc length is equal to r theta, which is just your radius, r, theta, which is your angle in radians. So it's easier than the degrees. So let's just do a few examples of the different types of problems. So on this first one, I've got a circle, radius of 100 degrees. Arc length I'm looking for is x. So again, I'm just gonna follow my basic setup and go arc, which is x, over 2 pi r. Okay, so I'm plugging r in for 7 and for r, so 2 pi times 7 is equal to my angle, which is 100 divided by 360. So 100 divided by 360. Now what I like to do before I cross multiply and clean it up is take off zeros if I can. Remember, that's the only thing you can take off. So cutting those zeros out. And then over here, 2 pi times 7 is 14 pi. Okay, so now I can just do a basic cross multiply. I've got 36x is equal to 14 pi times 10, which is 140 pi. Okay, and then from here I'm solving for x, meaning that I'm just dividing by 36. Okay, so I've got x is equal to 140 divided by 36, and we're going to want to reduce that fraction. Remember, don't plug this into a calculator. We don't want the decimal. We want the reduced fraction. And play with how you do that. Remember, guys, I like to take 2's out until I can't take 2's out anymore, and then kind of go on from there. So if I take a 2 out of 140 and a 2 out of 36, what I'm ending up with is 70 over 18. Taking another 2 out is going to give me a 35 over 9. 35 and 9, I can take, that's it, 35 over 9. I'm good. So I've got 35 pi over 9. And that's it. That is my arc length for there. Okay, similar up here. In this case, I've already set this up for you partially. We've got, again, arc over circumference, so x over 12 pi. 2 pi r is 6, 6 times 2 is 12. So x over 2 pi r, 12 pi is equal to 30 over 360. Again, I'm crossing out those zeros. Cross multiplying, I'm getting 36x is equal to 36 pi. Again, I want my x on its own, so I'm dividing both sides by 36. And that's going to give me x is equal to 36 over 36 cancels. Just a pi, okay? Lastly, this is given to us in radians, that's not degrees, 2 pi over 3. And remember, we just look at our super simple radius equation, and that's just arc length is equal to r theta. So I have arc length, which I'll call x, is equal to r, which is 5, times theta, which is 2 pi over 3. Okay, remember on this, we multiply straight across, so the only thing being multiplied is the numerator. 5 times 2 is 10 pi over 3. And that's it. That's all there is to it, okay? Thank you so much.